channel Knowledge Shop. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry for class 11. That is your part 2, and that is your class as your 35 class of the session. We had discussed about 34th in the last sessions as well. Talking about the last topic that we had discussed about is your silica, and that is in the normal form. That is always the most reactive because of the high SiO bond. Now we talk about further, and that is we'll discuss about the silicones that is comes under in it. That is very important, of course, for the NCERT and the examination that has been asked in your competition as well. So let's go for the same, and that is the silicones here. So before starting with the same, you just go for the subscribe and that you have. So here it is silicones. In terms of silicones, here they are the group of organization that is organosilicon polymer which have R2SiO as a repeating unit, and that starting material for the manufacture of silicones are alkyl or aryl substitute silicon chloride, which is RaSiCl4 minus N, that is R is alkyl and aryl group. When methyl chloride reacts with silicon in the presence of copper as a catalyst at the temperature of 573 Kelvin, various types of methyl are substituted. We are the chlorine, and in the same way chlorine of formula MESO or SiCl3, which is Me2 SiCl2 Me1 SiCl, that with small amount of Me4 Si that are formed. Hydrolysis of dimethyl dichlorosilicon, that is CH3 told twice SiCl3, that is followed by the condensation polymerization that yield a straight chain polymer. So let's go for the same, and I just go for some of the things that has been very important for it. So I just write it on for you, for if you are making the notes as well, it will be helpful for you. So let's go for it. They are groups of organosilicon polymer which have R2SiO as a repeating unit, the starting materials for the manufacture of silicons are alkyl or aryl substituted silicon chlorides, which is your RnSiCl4 minus N, where R is, this is R, and that is your alkyl and aryl substitute silicons. Okay, so let's go for it, and then we'll discuss about the substituted, that we have to form an equation here. So let's go for the same one by one, and that is the first we have is your 2CH3 Cl plus Si in presence of copper powder with the temperature that it has is your force 570 Kelvin. It forms CH3 whole twice SiCl2 in the presence of 2H2O it will release 2HCl, that is CH3 whole twice SiOH whole twice. Now we go further, that is the another equation. We'll use different sets so that you will get to know about it. Silicon OH CH3 CH3 OH plus in the presence it will release H2O. Process is known as polymerization and form silicon. In terms of it, here the change length of a polymer that can be controlled by adding CH3 whole thrice SiCl, which blocks the end as to be here, and that we have as follows. Here if you can see here, this will be making a pair and it will release OH here, and this is forming a water, and another it will be forming water, and now this is also released by H here. Okay, so it will release H2O. That's the reason the H2O has been not formed, and this is known as silicon. Now we go for the chain length of the polymer that can be controlled by adding CH3 whole thrice and SiCl, which blocks the end, as that we'll discuss. So silicon SiCH3 CH3, and this is CH3. This is silicon whole in. Okay, so here it has also formed H2O. That it forms. Now we go further here, that we discuss about it, and we form another equation. So here we go. Here in the same way we will discuss about the silicons, and that is about your that silicons being surrounded by a non-polar alkyl group are water repelling in nature, which is repelling means that is water hating in nature. They have in general high thermal stability, high dielectric strength, and resistance to oxidation and chemicals, and they have wide application. They are used as sealant, greases, electrical insulators, and for waterproofing of fabrics being biocompatible. They are also used in surgical and cosmetic plants as well. Now we go for the question here. What are silicons? For the what are silicons here? Here simple silicons consist of SiO and that is change in which alkyl or phenyl group occupy the remaining bonding positions on each silicon. They are hydrophobic, which is water repellent uh, in nature. So let's go for the same. That is hydrophobic, which is water repellent in nature. Now talking about the silicates here, that is the another one. So this is silicate. This is the 8th question inside question that we had discussed about it. The silicates here, a large number of silicates minerals that exist in nature. Some of the examples are feldspar, zeolites, mica, and asbestos. The basic structural unit of silicate is your SiO4 minus. So let's go for that. Here I will write it down as well. That is silicate minerals exist in nature. So that is in nature. Some of them are feldspar, zeolites, mica, and asbestos. The basic structure unit of silicates is SiO4 minus, in which the silicon atom is bonded to the 4 oxygen atom in a tetrahedral fashion. In the silicates, either the discrete unit is present or a number of such units are joined together via corners by sharing 1, 2, 3 or 4 oxygen atoms per silicates unit. When silicates units are linked together, they form chain ring sheet or three-dimensional structures. Negative charge on silicate structure is neutralized by positively charged metal ions. If all the 4 corners are shared and the other tetrahedral units, the three-dimensional network is being formed, and 2 important man-made silicates are glass and cement. Just write it down. that we have a structure here. This is tetrahedral structure. Representation of silicon oxygen here. This has been another one. Now we'll talk about zeolites. That is the last topic of it, of this unit. The P block element, zeolites. If aluminum atom replaces a few silicon atom in three-dimensional network of a silicon dioxide, overall the structure known as aluminium silicate acquires a negative charge, and cations such as Na plus, K plus or Ca2 plus balance the negative charge. Examples are feldspar and zeolite. Zeolites are widely used as a catalyst in a petrochemical. So just write it down. Zeolites are widely used as catalyst in petrochemical industries for cracking of hydrocarbon and isomerization. Example: ZSM-5, a type of zeolite used to convert the alcohols directly into gasoline. Hydrated zeolites are used as an ion exchange and softening of hard water. Now we're gonna end up here itself, and we'll discuss the rest in the next coming class. In terms of the P block elements here, the P block elements of the periodic table is a unique in terms of having all types of element, metals, non-metals and metalloids. There are the 6 groups of P block elements in the periodic table, numbering from 13 to 18. Their valence shell electronic configuration is ns2 np4 1 to 6, that has been numbered except for helium. Differences in the inner core of their electronic configuration that is greatly influenced by their physical and the chemical properties. As the consequences of this, a lot of the variations in properties among these elements is observed, and in addition to the group of the oxidation state, these elements shows other oxidation state differing from the total number of the valence electrons by unit of 2, while the group of oxidation state is the most stable of the light elements of the group, and the low oxidation state that becomes progressively more stable for the heavier element, and the combined effect of the size and the availability of the d orbital that is being considering here. And the same way, if we are considering that too as well, that influences the ability of these elements to form a pi bond, while the lighter element that form p pi bond, and that the heavier ones for the d pi or a d pi p pi and the d pi bonds. That absence of the d orbital in the second periodic element that limits their maximum covalence to 4, while heavier ones that can be exceed this limit. And where in the same way the topic boron as a typical non-metal, and that the other members are metals. So the availability of the 3 valence electron, which is 2s2 to p1, that for covalent bond, the formation that using for the 4 orbital, that is 2s 2p x 2py and 2pz, that leads to so called electron deficiency. in the boron compound, and this deficiency makes them a good electron acceptor, and thus boron compound behave as a Lewis acid. Boron forms covalent molecular compound with the dihydrogen as boranes, and the simplest of which is diborane, which is B2H6. Diborane contains the two binding hydrogen atom between the two, which is diborane, and B2H6. Diborane contains the two bridging hydrogen atom that between the two boron atoms. These bridges bonds are considered to be the three centered and the two electron bonds, and that the important compound of the boron with the dihydrogen are boric acid and the borax, and boric acid, which is BOH2 thrice, is a weak monobasic acid, and it acts as a Lewis acid by dissecting the electron from a hydroxyl ion. And borax is a white crystalline solid of formula Na2B4O5OH 8H2O. The borax bed text that gives the characteristics colors of transitions metals, where in the same way aluminum exhibits the +3 oxidation state with heavier element +1 oxidation state that get progressively stabilized on going down the group, which is the consequences of so-called inert pure effect. And in the same way, the carbon is a typical non-metal forming the covalent bond employing all of its 4 valence electron 2s2 2p2. It shows the property of the catenation, that the ability to form the chain or ring, and not only with carbon-carbon single bond but also with the multiple bond with the carbon double bond and the carbon triple bond, and that the tendency of the catenation that decreases the carbon that have more with the compared to the silicon, then of course compared with the germanium. In the same way, Sn is greater than Pb, and where the carbon provides one of the following the best example of allotropy, and where the three important allotropes of the carbon is diamond, graphite, and the fullerene, where the member of the carbon family mainly exhibit +1 and +2 oxidation state. The compounds in the +4 oxidation states that are generally covalent in nature, and the tendency of the show +2 oxidation states increases the more heavier element led in a +2 state in the stable, and whereas +4 oxidation state it is strong. It is a strong oxidizing agent, and the carbon also exhibits a negative oxidation state. It forms two important oxides, a carbon monoxide, carbon dioxide, and the carbon monoxide is a neutral, whereas the carbon dioxide is acidic in nature. Carbon monoxide having a lone pair of electron on the carbon form metal carbonalysis is a deadly poisonous due to the higher stability of its hemoglobin complex as compared to that of the oxyhemoglobin complex, and carbon dioxide as such is not a toxic. However, the increased content of the carbon dioxide in atmosphere due to the combustions of fossil fuels and decompositions of limestone is feared to cause increase in the greenhouse effect. This in return raises the temperature of the atmosphere and that causes serious complications. Silica, silicates, and silicons are important class of the compound and find application in industry and technology. Now we discuss the next rest in the next class, and that will discuss the rest of the p block elements questions, and after that we will continue with the next unit as well. So here we're gonna end up with this, and thank you. I hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.